There we go. I think I will go ahead and so I'm going to get version of the sorting program into the notes here. So if you didn't watch if you left early to try it on your own on Tuesday, now you can see what I did. It's definitely worth comparing what you did to what I did to see the differences. You may have taken a substantially different approach. Because I outlined a particular way of sorting before I posed the challenge, you may have come up with something very similar to this, but if you forgot that, you might have come up with something a little different. There are many different approaches to sorting. We've only looked at one of them here. So just to quickly kind of recap what we did last time is we wrote this sorting program, and let me zoom back in here. And the critical part of that is right here where it actually does the sort. It is of course important to understand how to read a list of numbers and store it in an array, how to print the numbers in an array as a list of numbers. You should understand how to do that, but the critical thing here is to try to understand how the sorting works. And this is what we ended up with. Now there was one thing here which makes this a slightly bad example, and that is that I kept track of the value of the smallest number so far, which meant that down here when it came time to swap, I could use that, which is fine, it works perfectly well, but it's not a great example of a swap, and we don't actually need to do that. So the first thing I want to do is let's create a variant of this program. I would suggest saving it a different file, you know, -1 or -a or something like that, just so you have different examples of programs that do the same thing in slightly different ways. And the variation I want you to try here is, instead of this smallest so far variable, we actually don't need that as long as we keep track of the smallest so far position. Because if we have that position, we can always go look up the value of the smallest so far from the array, right? Again, to kind of orient yourself conceptually, let's come back and look at our array. Let's say we are currently trying to fill in position number 2. We've already locked in the smallest and the second smallest number here, and we're ready to lock in the third smallest number. So as we are going through the list to find the next smaller number, we have the 91, then okay, 31 is the smallest. So up here we called this smallest so far, so we'd have a 31 there. This fill index champion are different variable names I used with the other class. You can probably figure out what I mean by those. But here I said fill position, smallest so far is the champion, and so forth. So smallest so far would be 31, and its position would be in position 3, right? So we'd have smallest so far position 3. But I don't actually have to keep, maybe I should zoom in here so you can see what I'm doing a little bit better. But you don't actually have to keep this smallest so far value. If you have the position, then you can just always look at that box in the array to see what that value is. So it's actually a little bit redundant to keep this number. So that's the variation I want us to look at, just so you see a bit of a different way. Plus it makes a better example of swapping when we get to the swapping part. So let's just take that out. I'm going to comment it for the moment. And then down here, when we find a number that's smaller than the smallest so far, again, we don't need to actually save that number in a separate variable because we already have it here. And that changes this if. Okay, the if is comparing to the value of the smallest so far to decide if we have something even smaller, right? As we're stepping through the list to find something, to whatever goes into the next fill position. But if we don't have that smallest so far variable, all I have to do is compare to numList at the position of SSF. Oh, whoops, I commented the wrong thing here. That's the one I want to keep. I want to get rid of smallest so far. So we want to keep the SSF position. If we have that smallest so far position, then I can just use numList bracket smallest so far position like that. And so this is looking up, this is finding the value of the smallest one I've found so far, comparing that to the challenger, the value of the challenger, and if the challenger is smaller, then I update the smallest so far position with the current challenger position. So that takes care of that comparison. Then when we come down here for the swap, we get something that looks more like a classic swap. Because I don't have the smallest so far variable, I actually have to use the item out of the array, which is again going to be based on the smallest so far position. Like that. And that gives us a little bit of a better example of doing a swap. And I wanted to do that simply because swaps, just the idea of doing a swap, is pretty important in programming. So this kind of thing is something that can come up quite often in different programming situations, not just sorting. They're just different places, different situations where you have something in one variable, something in another variable, and you want those two numbers to change places. And what you run into is if you just say A equals B, then you erase what's in A, and so you can't copy what was in A over to B, right? That's the slightly tricky thing about swapping numbers, and that's why you need some kind of temporary variable anytime you want to do a swap. So take what's in B, put it in, or take what's in A, put it in the temporary variable, then take what's in A, or take what's in B, put it in A, then take what's in the temporary variable and put it in B. That's the essence of a swap. So doing it this way without keeping this smallest so far variable all the time makes our example of a swap a little bit more of a classic example of doing a swap. And so I prefer that as an example. And it's always good to see that there's many different ways often to do the exact same thing in a computer program. And so let's actually just take those lines out, because I think I actually prefer this example overall anyway. So that does it. So this is our sorting program, and let's see. What I'd like to do just now, since we kind of just ended the last class with the sorting program, just are there any questions about this program, this example program, or sorting in general? Anything that's not clear? Yeah.
Is there any way I can look at that program compared to the one I made?
Yeah, I actually just saved it in the notes.
Okay.
So, well, I didn't actually. Let me put this one in the notes as well. The one before I just made these changes, that's in the notes right now. So that's over here and on this example sorting program from 2:30 p.m. class. So other than the slight change to how it does the swapping and the smallest so far, it's the same thing. But let me go ahead and get what we just did in the notes as well. Because yeah, I definitely want you, if you did your own, or at least tried to do your own, I want you to be able to compare what you did to what I did, and that'll help clarify your thinking. Maybe you'll see a little bit cleaner way to do things, that sort of thing. So let me get this other version here. I always have to change the font so it's small enough for me to get a screenshot, but copy and no, it doesn't. Okay, there we go. So this version has a better example of doing a swap. This version is from end of Tuesday's class. Alright, so you have both of those that you can compare what you did to, or if you weren't keeping up with me last time or whatever, you can catch up by looking at that. Okay, so any other questions, anything you want to clarify about this example of sorting? Anything? Don't be shy. Alright, so well, if you don't have any questions, I'm going to pose a question to you. Let's look at the sorting section here, in this loop within a loop. The basic thing we have to do in here is over and over and over again, we have to check, is the number I'm looking at a number that might be a candidate to go into the next slot that I'm trying to fill, right? And we have to do that over and over and over and over again in this inner loop. Then the outer loop goes around again, and then the inner loop goes over and over and over and over and over. Then the outer loop goes again, the inner loop goes over and over and over and over again. So the question I want to pose to you, if the list is, say, 5 numbers long, how many times do I do this part of the program right here? How many times do I hit that if? So got a 5-number list. how many times does that if get hit? And if you have to take a pencil and paper out, scratch pad to figure it out, it's not terribly hard to figure out. You just kind of have to do some counting. You're on the right track. You're basically right. Consider that the inner loop starts at fill position +1. You didn't quite do the correction, but you're on the right track to correcting his 15. Other way.
60?
No. 10. Yeah. So think about it. Okay, you've got 5 numbers. So when you're looking for something to replace the first number, you have to go look at 1, 2, 3, 4 things. Then you've got this one locked in. Then to replace this one, 1, 2, 3 things. Got this one locked in. 1, 2 things. Got that one locked in. 1 thing. You got that locked in. Right? So you end up doing it 1 plus 2 plus 3 plus 4 times, which is 10. But you're on the right track. I mean, you're just kind of, you were thinking start here, 1, 2, 3, 4, 5, then 4, then 3, then 2, then 1. So you're basically thinking the right thing. And the distinction between that 10 and 15 is not really that important. It's the essence of what was going on there that's truly important. But okay, so now what if it was a 10 number long list? Now how many steps is it going to take? Some of you might remember the mathematical formula for this, but it's not too hard to add up 1 plus 2 plus 3 plus 4 plus 5 plus 6 on up to 9. So what's that? Or you can bring up a web browser and type it in as a Google search, 1 plus 2 plus 3 plus 4, and find it that way. So how many times is it going to hit that if for a 10 number long list? 45. Okay, so it jumped quite a bit from 10 to 45. So if the list was 100 long, how many times is it going to hit the inner if? Who knows the mathematical formula for what we're doing? Anybody? Mathematical formula for the sum of 1 plus 2 plus 3 plus on up to whatever, on up to n. N times n plus 1. Well, for us it's going to be n times n minus 1 because we're actually only going up to n minus 1. So it'll be n times n minus 1 divided by 2. So if we have a list of 100 numbers, take 100 times 99 divided by 2. So that's going to be 99,900 divided by 2, so 4,450. Does that sound right? So what if the list was 1,000 long? Well, we can kind of estimate and just say it's the number squared divided by 2. So 1,000 long, that would be 1,000 squared divided by 2. So basically 500,000 off a little, a little bit less than 500,000. What if the list was 1,000,000 numbers long? 1,000,000 squared is 1,000,000,000. So you basically be looking at that if 500 billion times to sort the list of 1,000,000 numbers. What if the list was 1,000,000,000 numbers long? What comes after trillion? You've got quadrillion, quintillion. 10 to the 18th, does that sound right? Yeah. So half a quadrillion, basically. No, half a quintillion. Half a quintillion. Basically a bajillion times you have to look at that if statement, okay? If you get a really long list. Now, computers out there in the world are sorting lists of 1 billion things all the time nowadays. I mean, how many web pages does Google organize and sort and search through? Many more than 1 billion, I'll tell you that. But even if it only takes a few nanoseconds or microseconds to do this if right here, once you start getting into doing that a half a quintillion times, you might still be talking about, and if you want to do the math, you can check, but I mean, you're talking hours or days to do that sort. Okay? Fun, right? Here's another thing to think about. What if I was your torturer and I handed you a stack of cards with numbers on them, all in random order, and I forced you to sort that stack of cards? It's a nice big stack. Okay, let's not just a stack of playing cards, not just one deck of playing cards, but a nice big stack of cards about this high. All right, now I want you to imagine actually sorting that. All right. Would you do what we just did in this program? Would you go one at a time, find the smallest one and set it over here, and then find the next smallest one, set it over here? Would you do that? Who would do that? Okay, good. Good, you're all smart. What would you do? Okay, but there's somebody's pointing a gun at your head and says you have to sort those. It's life and death. That's an option.
Just lay them all out and look at it all at once.
Okay, it's a stack of cards this high. That's probably several thousand cards.
How big is the room?
It's a room this. Okay, you could, but you couldn't take them all in unless you have, like, I don't know, some kind of superpower to be able to see that many cards at once and take them all in. So does anybody have a thought about how you would do it and not actually take all that long? Yeah.
You could do it. You could do two piles, do high and low. That's still going to be much faster.
You're on the right track. Yeah.
I would just like put them in order, like as I kind of find them. So I would like take whatever the first number is, put that down, and then like keep on trying to, like, I guess, like make the pairs of numbers in a row. I don't know.
You're on the right track. You can kind of start to imagine what you might do. First of all, one of the things you might do is just take chunks. Take a chunk maybe about the size of a regular deck of cards or a little smaller, and then just sort that, which you could probably do pretty quickly. Okay? Set that aside, take the next chunk, sort that, set it aside. Then if you took these two, they're already sorted, then it's just boom, 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 take whichever one's smaller from the top and combine them. That's not too bad, right? That's kind of one way. Another way is you just go through them all, and if you kind of know what the big ones are and the small ones are, maybe, you know, everything from 1 to 100, you put a pile of all the 1 to 100s here, and everything from 100 to 200, you put that in another pile, and everything from 200 to 300, you put in another pile. Different kind of strategies like that. Well, perhaps not too surprisingly, there are various sorting algorithms, programs people have written, that take advantage of all those kinds of things. They're a little bit more complicated to write, but suddenly sorting 1,000,000 numbers, instead of taking 500 billion steps, maybe takes 20 million steps, which still sounds like a lot. But what is 20 million as a percentage of 500 billion? Tiny. It's much less than 1% of the amount of time. You're basically saving yourself like a factor of 1,000,000. You're doing the sort 1,000,000 times faster. You're talking about, instead of taking days, taking a second. Okay? Or taking years, taking a second. You know, taking a few seconds instead of taking years. So something I just want to put out there for those of you that like a challenge and a puzzle. See if you can come up with a way of doing sorting that tries to take advantage of some kind of trick that a human might actually do if they were faced with sorting stacks of cards. And see if you can come up with something that, if you gave it a list of 1,000,000 numbers, would not take days or hours or whatever it ends up taking, but only takes a few seconds. I just want to put that challenge out to you. That's actually kind of the underlying idea here of coming up with more efficient ways for your programs to run, coming up with programs that run more efficiently and getting these drastic speed ups. That's actually something for algorithms class, which is like the last senior level class that you want to take in computer science, in your computer science program probably. But since this is, you know, computer science 2, I'm putting this out there as this is the kind of thinking that you do as a programmer or a computer scientist. How do you write things more efficiently? So it's not something I'm going to give you as an assignment to come up with the more efficient ways of sorting, but they're not that hard. There are a few ways of doing it. The idea of splitting it into smaller piles and sorting each one separately, and then kind of merging them together once you have the smaller piles sorted. That kind of idea and similar ideas are definitely doable at your level. You could, if you want to, if you like the challenge of it, you could figure it out. So I suggest trying it, and then if you're interested, whether or not you succeed or fail, then you can Google and just Google efficient ways of sorting or things like that, and you'll find a Wikipedia page that talks about all kinds of sorts and gives you all kinds of ideas, and you can see examples of the programs and so forth, because people have been studying sorting for decades and decades now, and it's pretty thoroughly, both from a mathematical point of view and from an engineering point of view, pretty well studied topic. But well worth your time if you like that kind of challenge and puzzle. So I want to put that out there, and then what I'd like to do is let's look at the technique we've used here. And I didn't give it a name last time on Tuesday, but the kind of sort that we're doing is called an insertion sort, which is basically find the next number and put it into the location it's supposed to go. Find the next number and put it in the location it's supposed to go. Or you might call it a champion sort. Actually, you know what? No, insertion sort's not the right name for that. I don't know why I said that. I just told the other class insertion sort too. So that's wrong. Champion sort might be one way of putting it. Actually, is there a name for this sort? Now that I think of it. I'm not sure there's specifically a name for this type of sort. You can call it the champion sort, because each time through you're looking for kind of the current champion, and then that one goes into the slot. I'm going to have to look it up again if there is an official name of any sort for this sort. But at any rate, this is one way of doing sorting, but it's just one way. Obviously, I've hinted that there are much more efficient ways. There are other ways that are about as simple as this idea, but are quite different. So I just want to pose one of those to you, which might actually become a homework assignment. And that's on a different page. And that is the idea of a bubble sort. And you can't really see it here because all we have is a list of numbers right now. Let's see if nope, it's not going to let me do that. So let me mix these up a little bit, because they're already partially sorted from what they were. Yeah, that's fine. And let me zoom in on that a little bit. So we've got this initial list of numbers. So I'm going to describe this. I am successfully recording, so if you want to go back and watch the recording to see the description of bubble sort, you have that ability. But the idea behind the bubble sort is you start at the top. You could do it either way. You could start at the bottom, start at the top, and you check that number against the next number and see if they're out of order, and if they are, you swap them immediately. Okay, so here 31 should come after 20, so we get rid of the 20 there, put it up there, and put the 31 down there. So again, that involves a swap, which means you would actually want to have a temporary variable. Take one of those, put it in the temporary variable, move the other one, then take the temporary variable, put it into the other one. So once we've got those in order, then we look at the next two positions. So we look at the 31 and the 55, and we say, are those out of order? No. So, okay. Then we look at the next two, 55 to 33. Okay, those are out of order, so we do 33 here, and the 55 goes down there, so we swap them. 15 and 18, out of order, so the 18 up here, and the 55. 55, 777, in order, 77, 19, so 19 goes up here, and the 777 goes there. Next, so then the 3 goes up here, and the 7777 goes down there. Then again, swap again, swap again, swap again, right? So 22 here, 777 there, then the 91 comes up, and the 777 goes down. And finally, swap the last two because they're still out of order. And what have we done? We've done a number of, several things have swapped position here, but ultimately what we know has happened, what we can say for sure will happen is that the biggest number in the list gets pushed all the way down to the bottom, right? And now we can go back to the top and do it again. 20, 31, check. 31, 33, still in order. 33, 18, those have to swap. So 18 there and 33 there. 33, 55, that's okay. 55, 19 needs to swap. So that happens. 55 and 3 need to swap. So 55. 55 and 22 need to swap. 55 and 91, good. 91 and 82 need to swap. So far, so good. Then you go back to the top. Do it all over again. 20 to 31, check. 31 to 18, swap. 31, 33 are fine. 33, 19, swap. 33 and 3, swap. 33 and 22, swap. Start to throw things at me when you get bored. 33, 55, good. 55, 82, good. And I guess I didn't type the 91 down there. That should have been 91. Okay, so it's starting to get in order, but you can see where it's going. So you go back to the top, 20 and 18, they would swap, and then you pass all the way down, and eventually the 33 is going to be locked in, and 31 will be locked in, and the 22 will be locked in, and so forth, and you ultimately would end up with a sorted list if you did enough passes. The largest number of passes you would need to make is 10. There is a trick where you could cut it short a little bit. If you recognize that you didn't make any swaps all the way through, then you know it's already sorted and you can just stop. You don't need to make another pass. That's a slight complexity to the algorithm, but it may save a little time. So that's another fairly simple way of doing sorting, but it is significantly different than find the next biggest one and put it at the top. You know, find the next biggest one, put it in the next position. Two quite different ways. Now, a couple things to think about. One is that question I put to you earlier is how many times are you going to have to compare two numbers to see if you need to swap them? And is this really going to be, would this take more steps, fewer steps, or about the same number of steps as the champion sort that we were doing before? That's kind of a computer scientist-y question to ask yourself. Is this any more efficient or significantly more efficient, less efficient than the other way of doing it? It is a pretty easy one to understand, so I think I may actually give this one as part of the next homework assignment. Just basically rewrite our sorting program but using this method instead. So there, your goal is not just to get a sort working, but get a sort working in a particular way that follows a particular algorithm. So any questions about the idea behind bubble sort? All right, so something to look forward to on lab number 2. How much time do we have left? We have tons of time left. You guys are ahead of the other class. All right, I think the next thing I want to do with the time we have is first let's just talk about the homework assignment. So if you haven't noticed already, there are instructions up there. So on the Labs tab, we now have Lab OX01. Who knows what that notation is with the 0x? Hexadecimal. Somebody knows. Nobody knew in the last class. I was a little surprised. Somebody guessed octal, but nobody guessed hexadecimal. So yeah, this is a the 0x is just a one way of indicating that the number that you're showing is what we call a hexadecimal number. We may talk about hexadecimal in this class a little bit. Definitely, if you're going on with any kind of computer-related technical field, you should know what hexadecimal numbers are, how to read them. So I would say, I would highly encourage you, if you have never heard that before or only barely have some vague idea, Google hexadecimal numbers and just learn what they are. It'll take you 15 minutes to understand them thoroughly. But the essence of them, essence of hexadecimal, hex meaning 6, dec, D-E-C, des, meaning 10, so 6 plus 10 meaning 16. Hexadecimal refers to what we call base 16 numbers. So instead of digits that go 0 through 9, we have digits that go 0 through 9, A, B, C, D, E, F. And the A, B, C, D, E, F just represent 10, 11, 12, 13, 14, 15. And then you can count and do addition, whatever, with hexadecimal numbers exactly the same way you do decimal numbers. I'm not going to go into why they're important in computing and computer science right now. But so here, this is Lab OX01. Again, the OX, all that means is that this is hexadecimal. Other than that, you know, I could just leave that out and just tell you that that's a hexadecimal number instead of a decimal number. But this is just kind of a traditional way to indicate that you are writing a number in hexadecimal. And it's also, for example, in many programming languages, if you want to write numbers in hexadecimal instead of decimal, this is the actual syntax that you use. So normal counting works just fine. 0, 1, 2, 3, 4, 5, and so on, up to 9. Then 10 would be A, B, C, D. So E is 14, F is 15, and then if you want to go to 16, then just like 9 rolls over to 10 in decimal, F rolls over to 10 in hexadecimal for 16. So that's a 16 in hexadecimal. And then 1, 1, that's 17, 1, 2, that's 18, and so forth. For 32, 2 times 16, that's 20, just like 2 times 10 is 20 in decimal, 2 times 16 is 20 in hexadecimal. So that's your quick introduction to hexadecimal. So here's the homework assignment. And I just want to call your attention to some things. You should bring this up and actually read it now. Make sure you understand my instructions. I think there's already some things I want to clarify. Despite trying to be very detailed and very thorough, there's always things that throw people off. So first I have a section of what to turn in, just to make sure you have a highlighted list of things. I don't want that to be yellow highlighted there. Let's highlight that a different color. There. So there's going to be one program file to turn in and a choice of one or two or both of these to turn in, and then a Word document of screenshots. So I will always try to have this what to turn in at the top so you have a quick reference to make sure you've done everything for the homework assignment. And for your program, since you're probably writing them in your virtual machine, the easiest way to upload those to D2L is to run Firefox within your virtual machine and connect to D2L that way. So if you haven't seen that, just to make sure you have seen it, if you come into your virtual machine, down here you should have a Firefox button, or you can find it over in the menu somewhere. But if we click Firefox, bring up Firefox, you can run Firefox in your virtual machine. Your virtual machine should have access to the external network. So then in here we can do D2L .sdbor, SDBOR, does that sound right? .edu. And there you are, you're at D2L, and you can log in, find your classes, find your Dropbox, and upload files from your virtual machine directly to the Dropbox. Now you'll probably do your screenshots with snipping tool in Windows, so that file, your Word document and so forth, you'll probably have in your Windows machine. So there you just log in normally with a web browser for Windows. And so that's how you can get those uploaded easily. You can also copy and paste into Notepad and save a file on your Windows machine to upload your .c program files. Okay, so now the Word document of screenshots. This is kind of a show your work kind of thing. Your screenshots you should probably just get your whole screen so that I can see the name of your virtual machine. So it's partially just kind of a minor way of kind of proving that you're doing the work on your own machine kind of thing. And it's also showing your work. It lets me get a better sense of what you did, and if you were having trouble, what kind of problems you were having. So you want to try and kind of get a side-by-side, have your program in the editor. It's kind of, if I bring up my virtual machine, let me exit Firefox. So the kind of screenshots you probably want to get are, have your program on one side, and you don't have to have the giant fonts that I do to make things visible on the screen there. But once you have something sorted, actually I can throw up, I believe. Did I never actually run the sort for you guys? Oh wait, my virtual machine got shut down, so I don't still have that there. Okay, so so if we gcc and /sort number to list, and we give it 5 numbers and 12, 44, 88, 2, and 77. And here's your list sorted, 2, 12, 44. So that's the kind of thing you would want to get a screenshot of, this sort of thing. Now maybe, I don't know, you make a mistake in your program, you can't figure it out, and you're running out of time. So I'm deliberately putting a mistake in there. I mean, wait. Oh, that's probably not a good mistake. That wasn't actually a mistake. Let me actually delete a semicolon. It's fine with, generally if you put extra semicolons between instructions, it's actually fine with that. So there we go. So I don't know, you get some error messages when you try to build, or you run it and it doesn't work quite right, and still get screenshots of this sort of thing. Submit that in your Word doc that you put up with your assignments, and it's all stuff that I can give you extra credit. Also in the Word document, I mean, if everything's working fine, you don't really need to add commentary, but if you're having any issues, or maybe you did some experimenting that you thought was cool, you know, you can put extra text in your Word document explaining what your images are showing me, or explaining what problems or what you were thinking when you were trying to solve the problem. Anything like that is good as far as getting extra credit on your, or not extra credit, but getting some kind of partial credit if you did not get the program you were supposed to write working perfectly. Okay. Then down here we have general requirements. This is pretty much going to be applicable to every lab that we do. When you write your programs, as I've already said, be creative, personalize the messages. And unless I explicitly say the output of your program should look exactly like whatever, I want you to be creative and make your program uniquely yours. And that should include some kind of little welcome message at the beginning of your program and a farewell message at the end of your program. It doesn't have to be quite this elaborate with all the fancy border and everything, but you know, be creative, do something, take some pride in your work, and make the program uniquely your program is what I'm going for there. So give your program a personality, and you can be snarky, you can, you know, be humorous or dull and boring, whatever you want to do, that's fine. Give your program a personality. Basically, I'm kind of saying have a little bit of fun with these assignments, no matter how dull they might happen to actually be. Hopefully the actual programming problem part is interesting, but if not, you can have fun with your printf messages. Okay, so then after all that preamble stuff, then you should find each of the programs that you're supposed to write. So here's program 1, which was the in-class thing. Now since this is now outside of class and you have plenty of time, the extras and so forth are part of this. So I've detailed everything that you're expected to do here. And then program 2, I've given actually 2 versions of this that you can choose between, a basic and an advanced. And let me clarify, this is not extra credit, it's for full credit. That's a question that came up with the last class. So so doing the advanced one, this is just like ideally to get an A on this or an A+ on this program number 2, you would want to complete the advanced version. But I wanted to give you kind of an example of how you can simplify programs for partial credit. So if you look at the actual instructions that I've put here, if I did not give you this basic version already, you might come up with your own basic version. So if you're looking at the instructions saying, well, there's a whole lot of complexity, what is the essence of this? What is the most important part? What is the most basic part of this? I'll do that and make sure I get that working and turn that in. And then if I have time, I'll do some more of the requirements for the program. Okay, so this kind of gives you an example of how you can do that kind of fallback. So if I only gave you these instructions for the advanced one, you should, when you're working on your homework, feel free to simplify down to the basics and make sure that you can get something working that more or less does what's asked, and then worry about some of the complexities. So for palindromes, the simplest idea of a palindrome is that you've got text that's the same forwards and backwards, right? So at least do that. Okay? That's basically what this PalCheck basic program says, is at least be able to check these things forwards and backwards. Then the PalCheck Advanced says, okay, give your program some different options. So you can, do you ignore punctuation or do you include punctuation as part of the palindrome? Okay, is it case sensitive? Does does a capital A match a lowercase a, or do they not match when you're considering whether it's a palindrome? And I've also added an option for a quiet mode, which basically means if you use that quiet mode option, then your program should not print the welcome message and farewell message. And let's see. One thing I should clarify here, and I will add some stuff to some tips to this, just to make sure it's clear what I'm asking you to do. And let me mention that as well. So once I have these instructions up there, if you send me questions, or even if I just think of other things that need clarification, I will typically create a page below the instructions called Tips and Clarifications, and then on that page, during the week before it's due, I will add anything I think of or that comes to me from questions from you via email or whatever. I will put in here anything that I think people might need to know that would help them out. So even if you've already read the instructions and think you know everything you're supposed to do, it never hurts to come back and see if there's a new tip that might help you out. Let's see, what else should I say about this? So I do want to, there is a clarification I want to make about this palindrome checker right now, which is that the palindromes that you're checking are themselves going to be command line arguments. So if we think about what this will look over here, let me it doesn't want to do that. Make sure you can see that. So when you go to run your program, it might be like pal check basic, and then you would say ABBA, or if you want a command line argument to have spaces in it, you can just put it in double quotes. So you could do the a man, a plan, a canal, Panama, is that right? Something like that. So is that a palindrome? Whatever. And another one. So that's how you would run your program, and your program is supposed to look at each of these command line arguments. So each of these would be in one of the elements of argv and determine, is that a palindrome? Okay? So that's the essence of what's going on there. So that's the basic one. Now the advanced one has these options. So notice that in Linux you've seen at least a few, like the ls command. A standard thing in Linux is that when you have commands, there's different options for those commands that change what it does. So like the standard ls command just lists your files. The ls-l is like the long form, which lists them all in one column, and then you get all this information about each file, like its last time modified, its size, who the owner is, that sort of thing. There's ls-a, which shows hidden files if they exist. So here, every file name that starts with a dot is a hidden file in Linux. So here we're seeing a bunch of files that we may not have seen before. And that's a standard thing with all kinds of Linux commands. In fact, like the gcc command, we've been using an option there all along. So, we do whatever.c and then -o to rename the output file so that the executable file is not a.out, it's something sensible, like whatever, right? So this -o is an example of an option to a Linux command. So we're kind of doing that in this assignment. So you would do something like /pal check advanced, and let's say you wanted it to include punctuation when checking the palindrome. So you'd have the -p option. Or if you wanted it to be case sensitive instead of the normal, which is not case sensitive, then you'd use the -c option. Okay? Or if you wanted it to not print the welcome message, -q option. All right? Or you could combine options. You could do all three options, -QPC. It shouldn't matter what order they appear in, PCQ. Any sequence of options is fine. But if that first command line argument starts with a dash, then instead of it being a string that you want to check as a palindrome, it's options that change the way your program works. So your program will have to look at that argument. You have to have an if-then. Is the first character in that argument a dash? And then some more if-thens that look at the other characters to see if there's a P or a C or a Q. And if the user puts in something that is not a valid option, like -X, then your program should kick back invalid option and maybe print a few lines showing the correct way to use the actual options that are valid. So that's the idea behind the advanced. It just gets a little bit more into what real programming feels like. You don't just have a simple little problem and just do that, but having options and ways of making a program behave differently is a more realistic programming problem. And so again, when you think in terms of how I'm going to grade these things, think of it, if you get the for that one problem, for program number 2, if you just did the basic one and it worked perfectly, that's somewhere in the C+, B- range. And then if you did the advanced one, depending on how well you did on it, then you're getting into the B+, and up into the A range for that specific problem. Even if you didn't get the basic one completely working, there's still potential for partial credit that gets you into the C- territory. So just to kind of give you a rough idea how I grade things. Yeah, any questions about any of that? Yeah.
So like the comments are like when at the top you mentioned like document like any special links that happen along the way. You want us to do that in the Word document next to the screenshots then?
Yeah, I mean if there's anything you want to call my attention to, or you want to clarify, or particularly if you didn't get it working, but you want to tell me something about what you were thinking. Yeah, and I definitely encourage experimentation. So if you like doing this and you think of something cool and you want to try something a little different, throw screenshots in there. Tell me what you're doing. Can't hurt as far as partial credit, extra credit sometimes, just depends. I did not include a challenge problem, which would be actual extra credit, but most labs will probably have a challenge problem that will be worth quite a lot if you do it. And I'll try and remind you of this again, but challenge problems can really be worth a lot. Like potentially some of them, if you did a challenge problem perfectly, would be worth as much as a regular assignment. So they could replace a 0 that you had earlier or something like that, or later. Not all of them will be that way, and I'm not going to announce ahead of time how much any given challenge is worth. The other thing I'll say is they're not always harder than the main assignment. So sometimes you might want to do the challenge problems first. So just kind of keep that in mind as we go forward and you get more lab assignments and I give challenge problems. Any other questions about any of this stuff? All right. What I'd say is let's use the remaining time. Go ahead and read those instructions and just get a start at least thinking about the homework problem and see if you have any questions about the instructions and what you're actually supposed to do on either problem. I'd say read the full instructions of both programs first, rather than just the first one. Yeah. So that's it for we'll just use the rest of the time that way and take it from there.
Also, do you want the same Word document for the whole?
Yeah, just do one Word document for the whole assignment. Just put it all together in one.
All right, and when will Dropbox be open for that?
I think I already have it.
All right.
If you want to check and see whether I actually made it visible, actually, let's see. I think yep. And I do not have a classwork screenshots folder yet. Wait, I didn't give you guys a classwork screenshots for week 3, did I? Looks like I did not. I think I'll just do a combined one for week 3 and 4. Did I make it visible?
So it is okay if we don't use the Linux VM? We just use Bash on Windows?
Yeah, generally speaking, that's fine. I mean, if you run into something where I ask you to do something and you can't do it with Bash on Windows, then you might think about getting the Linux VM, or at least discuss it with me so we can resolve whatever it is. But yeah, I mean, it's in terms of just, okay, you wrote a program and run it and it interacts with the command line, that I think should work the same way in Bash on Windows as what you see me doing here.
I'm just using Sublime Text on Windows and then
yeah, I think that should be fine. Let's just play it by ear, and if you see an issue, then we'll figure it out.
yeah, because you can actually access the C drive within the Linux environment with the Bash shell on Windows too, because it's mounted
Oh, okay.
in the MNT folder. So
Yeah, so one thing I haven't shown you with Mint is there's a way to set up a shared drive between the host machine and the virtual machine. They can share a drive, and so you can move files back and forth that way. The bidirectional drag and drop files might work okay now. Like I said, that used to be buggy, so I just haven't bothered testing it recently.
yeah. How long ago was that?
It was actually, I think it was about a year ago that I gave up on it, and so I haven't really tried it since then.
They might have made that better now.
Yeah, there's a good chance. Yeah, I mean, there's a good chance they've done some bug fixing since then. Quite a few version numbers have gone up since then. Yeah, so it's 3:42. Class is basically over. But, you know, it's my office hours for the next 30 minutes, so I can hang out here if you want to keep working on it while I'm here for you to ask questions. Feel free, or take off, whichever you prefer. How many of you would have stayed here another 15 minutes if I didn't say anything?
I'm just waiting for the time that it's socially acceptable for people.
Ah, okay.